سلام الله عليكم طلاب مبادئ الإحصاء، وإن شاء الله يا رب تكونوا بخير وصحة وعافية. نكمل موضوع بلشنا فيه موضوع البروبابيلتي. الفيديو اللي فات كتبنا مقدمة عنه شو يعني random experiment، ومنها كيف نطلع السامبل سبيس يعني الست of all possible outcomes، وأي جزء منه سميناه event، وعن صنفناه لأربع أنواع events: simple, composite, impossible و certain event. وحكينا انه الامبوسيبل ايفنت دائما البروبابيلتي 0 والسيرتن ايفنت البروبابيلتي 1 واي ايفنت في الدنيا البروبابيلتي 0. هلا في 7 قوانين البروبابيلتي حاعتمد عليها في الشابتر كله، هون علشان نكمل هذا الشابتر لازم نحفظ هاي القوانين ونتقنها مضبوط. بتعتمد هاي القوانين مشتقه من فين دايجرام. في 2 فين دايجرامز رسمتين بدي ينحفروا في الذاكره عندكم كامل. إذا مثلت السامبل سبيس كلها لكل البوسيبل اوتكمز بهذا الست، وأخذت أي جزء منها، مثلا هذا الجزء سميته الإيفنت A، ما تبقى بسموه A complement، the complement of A، مكمل complement of A. A and A complement، the union of A and A complement gives omega. A and A complement, the union gives omega. Omega, the probability of omega certain event is 1. So probability of A plus probability of A complement is equal to 1. مجموع البروبابيلتيز دائما واحد ل A و A complement. فأول رول اللي بنستنتجه رول نمبر 1 إنه probability of A complement is 1 minus probability of A. Or probability of A plus probability of A complement is equal to probability of omega which is equal to 1. هذا أول Venn diagram. ثاني Venn diagram بدي ينحفر بالذاكرة عندكم، هذا الأهم. A, B. The common region بين A and B called A intersection B. تقاطع intersection بين A and B. هلا باقي المناطق، هذا region, this region can be represented by intersection. But شوفوا الديفرنس اللي موجود عندنا. هذه inside A and inside B. This region inside A but outside B, خارج B. But this is called A only. When I say A, anything outside A is called A complement. Anything outside B is called A B complement. This region inside A but outside B. This region inside B but outside A. Well, this region outside both A and B. اللي تحفظوا لي هذا الشكل. You have to memorize this. This is inside both A and B. This region inside A but outside B, A only. This one inside B but outside A, B only. This one outside both A and B. Neither A nor B. The 2 circles together, these 3 regions, is called the union of A and B. With the rest, the outer region is the complement of the union, outside the union. So these 2 statements are equivalent. These 2 are equivalent. Rule number 2. Rule number 2, we need to find in terms of AB and the intersection, this region. This region is part of A. أي جزء من A, part of A without the intersection. And when I ask you to find this region, probability of A intersection B complement, this is equal to probability of A minus the intersection. So it's probability of A minus probability of A intersection B. Similarly for this region. This one is B only, is called B only. Probability of B only or A complement intersection B is equal to. This region is part of B without the intersection. So to find the probability of A complement intersection B, it's probability of B minus probability of the intersection. Rule number 3, we have 7 rules. If we need to find the probability of the union of these 3 regions, the sum of these 3 regions, probability of A union B, this is equal to probability of A plus the probability of B, but when we add A and B, we will get the intersection twice, like يطلع عندي intersection مرتين وعندي اياه مره واحده هون. But we need to subtract the probability of the intersection. Rule number 4. نتعلم definition جديد. A and B. Or before this definition, we can put another rule number 4, اللي هو called Dmorgan's laws. حيمر عليكم مستقبلا كثير موضوع هذا دي مورغان. شو حكى دي مورغان بكل بساطة؟ دي مورغان قال إنه probability of A complement intersection B complement for this part is equal to the probability of this part because they are equivalent. هذول بيكونوا زي بعض. فإتس probability of A union B all complement. Intersection becomes union, the complement for the whole set. Similarly, probability of A complement union B complement becomes probability of A intersection B but all complement. لأن أنا بدي أضيفه على هذا الرول من هون. Probability of A complement is 1 minus probability of A. Probability of B complement 1 minus probability of B. Probability of X complement 1 minus probability of X. Probability of anything complement 1 minus that set without complement. So you can add here probability of A union B complement, it's 1 minus probability of A union B. And for this one, A intersection B complement is 1 minus probability of A intersection B. Rule number 5. You have to memorize these 7 rules. وتحفظوهم السبعة عشان نعرف نكمل عليهم. Rule number 5 شو رايك؟ two events A and B are said to be mutually exclusive, or sometimes they call it disjoint sets or events, if one of the following conditions is satisfied. Only one of these 2 conditions. If the probability of the intersection is equal to 0, or any one of them is sufficient. أي واحد فيهم كافي أحكي عن mutually exclusive. بحكي عن mutually exclusive if there is no intersection between them. يعني هي prospect تيجي A and B and no intersection between them. Or we can find it or determine whether they are mutually exclusive or not. If we look at this rule, union is A plus B minus an intersection, but the intersection is 0. So probability of A union B equals the sum of probability of A plus probability of B. Any one of them is enough to prove that A and B are mutually exclusive or disjoint. Another definition, number 6. A and B are said to be independent if they do not influence each other. ما بيأثروا على بعض. شو يعني ما بيأثروا على بعض؟ Like tossing a coin. لما ترمي كوين طلعت head or tail، ترمي الثانية بغض النظر عن الأولى، head or tail، الثانية ما لها علاقة فيها، بضل probability إنها للhead 1 out of 2 والtail 1 out of 2، فما لها علاقة فيها. نفس الشيء لو معي دارت أسهم وعندي هدف ثابت fixed target، بدي أرمي هذا الدارت، إذا البروبابيلتي إني أصيبه 70%، إذا أنت بدك ترميه شو ما كان أنا البروبابيلتي تاعتي ما بتأثر على البروبابيلتي تاعتك. نفس الشيء لو عندي بوكس فيه 10 balls numbered from 1 to 10، عندي 10 كرات منقبين من 1 ل 10، بدي أسحب واحدة، سحبتها. One ball is drawn, the number is noticed, then we replace the ball. رجعناها على الصندوق، خربشنا. Select another one randomly. هلا regardless the number of the first ball, probability of the second one remains the same. It's 1 out of 10. بس if the selection was without replacement، يعني انت سحبت واحدة وما رجعتها، نقصوا واحدة صار عددهم 9 أقل من الأولى. فالprobability of selecting the second ball is affected by the probability of the first ball, so they are not independent. How to determine whether they are independent or not mathematically? Mathematically, they are independent if the following condition is satisfied. If A, probability of A intersection B is equal to the product of probability of A times probability of B. This is only when they are independent. So when they say they are independent, we use this rule to find the intersection by multiplying A, probability of A, and the probability of B. The last one, rule number 7, is called the conditional probability. احتمال المشروط. Written as probability of A given B. This is read as, you can read it, given that. A given B. When I say find the probability of A given B, I mean we are restricting our sample space to B only. يعني احنا عم نصغر sample space ل B. Look at this in the diagram again. If this is the sample space, out of B, what is the probability of A? This is the common part of A and B. Thus the probability will be probability of the intersection out of the total, which is probability of B. So probability of A given B is equal to probability of the intersection over probability to the event after the given sample. It's probability of B. So probability of B given A is the intersection over probability of A. Notice that A intersection B is equivalent to B intersection A, and B intersection A union B is equivalent to B union A. It's commutative. You can interchange between A and B, getting the same result. Note, last thing about these rules. If A and B, we need to match between 6 and 7. If A and B are independent, suppose that you know that they are independent, then this rule becomes probability of A given B. I will rewrite it only. It's probability of A intersection B over probability of B. But when they are independent, the intersection can be replaced by probability of A times the probability of B over probability of B. Probability of B cancels with probability of B, so it's probability of A. Thus, if they are independent, probability of A given B is equal to probability of A. This is another condition if they are independent. So we know that A and B independent, if one of these conditions is satisfied, one of them enough. The intersection equals A times B, or the given equals to A, regardless of B. And بغض النظر عن B, A given B, they are independent بيطلع A نفس الحاجة. هدول السبن rules you have to memorize them تحفظوا لي اياهم. بدنا نبلش نتدرب عليهم بأسئلة. تعالوا شوفوا هذا الاكزامبل اللي بدي اكتبه. حط اكزامبل شامل لمعظم القوانين. Example. Given that probability of A is equal to 0.8, probability of B is equal to 0.7, and probability of A intersection B is equal to 0.6, then find number 1, probability of A complement. Number 2, probability of B complement. Number 3, probability of A intersection B complement. 4, probability of A complement intersection B. 5, probability of A union B. 6, probability of A complement union B complement. 7, probability of A complement union B complement. 8, probability of A complement union B. 9, probability of A union B complement. 10, probability of A given B 11, probability of A complement given B. 12, probability of A given B complement. 13, probability of A complement given B complement. And finally 14, probability of A given B all complements. And before you start solving any question depending on these rules, I prefer you to find these three properties. Before you start, you have to know A, B, and the intersection. If you know these three, you can apply all the rules. If one of them is unknown, like the intersection, maybe sometimes the question will give you A, B, but instead of the intersection, will give you the union. And if you know the union, A and B, you can find the intersection. Find it first, then continue to solve the question. Now all of them are given, A, B, and the intersection. Let's start with the first one. Probability of A complement. Just memorize the rules and apply them. This is the rule for A complement. It's 1 minus probability of A, which is 1 minus probability of A is 0.8. It's 0.2. Number 2, probability of B complement. Same rule. Instead of A, we have B. So this will be 1 minus probability of B. It's 1 minus 0.7 equals 0.3. Number 3, probability of A intersection B complement. This is rule number 2. Just apply this rule. A intersection B complement is probability of A minus probability of A intersection B. Probability of A is 0.8, the intersection is 0.6, the difference is 0.2. Number 4, it's probability of A complement intersection B. Same as number 2, the second part. It's probability of B minus probability of the intersection, which is equal to 0.7 minus 0.6 equals 0.1. Just apply the rules. Find the suitable rule and fit the rule in the solution to the correct answer. Number 5, you have to find the probability of A union B. This is the rule for A union B. It's probability of A plus probability of B minus probability of A intersection B. Rule number 3. We are done for rule number 3. Just substitute the numbers. Probability of A is 0.8 minus 0.7 minus 0.6, which is equal to 0.9. Part 6, we need to find the probability of A complement intersection B complement. If both have complements, then this is De-Morgan's law. A complement intersection B complement is equal to probability of A union B all complement, which is equal to 1 minus probability of A union B. It's 1 minus, this is A union B, its probability is 0.9, the answer is 0.1. Number 7, we need to find probability of A complement union B complement. And this is the second part of De-Morgan's law. It's a probability of A intersection B all complement, which is equal to 1 minus probability of A intersection B. 1 minus the probability of the intersection is given by 0.6, which is equal to 0.4. So we are done with De-Morgan's laws. Number 8, and this is the most important one. It's probability of A complement union B. Between the 7 rules, you will not find a rule written in this form. The only rule we know for the union is the third one, this one. But look at these two probabilities, these two events. It's A union B, and this is A complement union B. We can apply this rule, but instead of A, we can use A complement. So this is equal to the same rule as this one, but instead of each A, we can write A complement. So it's A complement intersection B. A complement, we found A complement before, it's 0.2. Probability of B is given by 0.7. A complement intersection B given by part 4 is 0.1, which is equal to 0.8. Number 9, A union B complement. Same thing, we will apply the same rule for the union, but instead of each B, we will use B complement. So this becomes probability of A plus probability of B complement minus probability of A intersection B complement. A given in the question is 0.8. B complement, we just found B complement in part 2, it's 0.3. Minus A intersection B complement by part 3, it's 0.2. And the answer is 0.9. Now, for part 10, we need to find probability of A given B. Apply the conditional probability. It's A intersection B over probability of B, which is equal to 0.6 over 0.7. You can leave it as 6 over 7. For part 11, you are asked to find probability of A complement given B. We will apply the same rule, but instead of A, we will use A complement. So this becomes probability of A complement intersection B over probability of B. But we did A complement intersection B in part 4 was 0.1. B is given by 0.6. The answer is 1 over 6. Part 12, you have to find probability of A given B complement. Same thing. Apply the conditional probability, but instead of B, use B complement. We found the numerator, A intersection B complement in part 3. It was 0.2. And in part 2, we found B complement was 0.3. So the answer is 2 over 3. 13, find A complement intersection B complement. Same thing. We will apply the formula, the condition for the conditional probability, but instead of A, we will use A complement, and instead of B, we will use B complement. And we found the numerator in part 6 by De Morgan's law. It was 0.1, B complement 0.3, so it's 1 over 3. Finally, we have to find probability of A given B odd complement. How to deal with this case? A given B odd complement, like this one. Union odd complement is 1 minus the union. Intersection odd complement, it's 1 minus intersection. So given odd complement, it's 1 minus. These two are not equivalent, which is equal to 1 minus. We found that A given B is 6 over 7. The final answer is 1 over 7. This is B point 1 over 7, and this is 1 over 7, sorry, by mistake. It's 1 over 7. The answer is 1 over 7. Now, this probability differs than this one. They are not equivalent. If you can see the answer, it's equivalent to this part. So you can memorize it as, take it as a note. If you want to find probability of A given B odd complement, you cannot use the complement for both. You will use the complement for A only. These two are equivalent. And the proof is left for the students. You can prove it, just apply the formula and you will get the answer. Now, in this question only, that consists of 14 parts, we applied 5 rules out of 7 rules. Let's consider another example to apply the other 2 rules that we didn't mention in this question. احنا استعملنا القوانين السبعة كلهم، 5 من السبعة كلهم إلا قانونين الاندبندنت والميوتشوالي اكسكلوسيف. هلا بعطيكم اكزامبل عليه. Look at this example. If probability of A is equal to 0.6, probability of B is equal to 0.5, and I will not give you the intersection, I will give you the union by 0.8. Are A and B mutually exclusive? Independent? Or neither? I told you before you start, you have to, it's better for you to find an A and then the probability of A, probability of B, and probability of the intersection, not of the union. Now, using the rule of probability of A union B, the third rule written before, it's probability of A plus probability of B minus probability of A intersection B. Applying this formula, we can get the probability of A intersection B. Since the union is given by 0.8, A 0.6, B 0.5 minus probability of A intersection B. Solve this equation by moving probability of A intersection B to the other side and move 0.8, 0.6 plus 0.5 minus 0.8. So probability of A intersection B equals, use your calculator to find the answer, it's 0.3. Now, we can now answer the question. Are A and B mutually exclusive? We say that A and B are mutually exclusive if they are disjoint, no intersection between them, which means that the probability of intersection should be 0. But here the probability of intersection is 0.3, it's not 0. And hence, A and B are not mutually exclusive. They are not mutually exclusive. Are they independent? The rule for independence, this rule is satisfied, then they are independent. If the product of probability of A and the probability of B equals to the intersection, then they are independent. Now, probability of A times the probability of B is equal to 0.6 times 0.5, which is equal to 0.3. Now, since the intersection we found before here is 0.3 equals to the product of A and B for their probabilities, then A and B are independent. Now the solution is completed and A and B are independent. Let's take another example. If A and B, given that they are independent events, such that probability of A is equal to 2 times the probability of B. It's twice the probability of B. And probability of A union B is equal to 0.8. Then find probability of A. This question can be solved in several ways, but the best way I recommend to use is as follows. أنا أكون معطيك A in terms of B, A بدلالة B. Let's call the smaller one, the smaller probability, let's call it X. A twice B, أدها مرتين, so B is the smaller one. So probability of B is X. And when you replace probability of B by X, A becomes 2X. This implies 2X is equal to probability of A. If you need to find the intersection, and we know that they are independent, so we can use this formula. The intersection is equal to probability of A times probability of B. So multiply X by 2X, it becomes 2X squared. Now, all of them are in terms of one variable, which is x. Now, let's use this fact. A union B is 0.8. The rule for A union B is rule number 3, given by probability of A plus probability of B minus probability of A intersection B. The union is 0.8, A is 2x, B is x, and the intersection is 2x squared. Add the like terms, they will be 3x minus 2x squared. This is a quadratic equation. معادلة تربيعية من معادلة الدرجة الثانية. Move them to one side. 2x squared minus 3x plus 0.8 is equal to 0. How to solve this equation? معه graphic calculator بسرعة. في calculators عادية scientific calculator كاسيو فيها equation في المود بتحلها برضه. If you don't have a graphic calculator, you can use the formula minus b plus minus square root of b squared minus 4ac over 2a. So x is equal to negative b becomes positive 3 plus or minus negative 3 squared minus 4 times 2 times 0.8 over 2 times 2. كلكم بتعرفوها هاي من المدارس. So 3 plus square root of 9 minus 4 times 2 times 0.8 all over 2 times 2. The first value is 1.15, or x could be, we use minus between them, 3 minus the root. The answer becomes 0.347. 0.347. X is a probability of B, and any probability, we say in the previous lecture, cannot be more than 1 or less than 0. It's between 0 and 1. So this one is rejected, and hence probability of B 0.347. هلا كل هالحل انت بسؤال multiple choice وقفت هون حتلاقي هالجواب 1 بس جوابك غلط، لأنه شو طالب السؤال؟ probability of A. Probability of A is 2x. So probability of A is 2 times 0.347, which is equal to 0.694. It's 694. هذا تطبيق على الرولز اوف probability. بقى كفيكم لليوم راح اكتب بهذا القدر. ضروري تحفظوا هاي القوانين وتتدربوا عليها مظبوط، وبدونها يعني ما بنعرف نكمل الشابتر. ونشوفكم على خير في المحاضرة القادمة.